All right, for today's lesson, we're going to, well, first of all, we're starting a completely new unit on exponential functions, solving equations, graphing, maybe even some word problems in there with exponential functions. Something we certainly haven't seen this year in this class, and you probably saw a little bit of it, Algebra 1, 2, but not too much. But that's our whole new unit. The focus today is going to be on graphing them. And so let me show you a problem. So this is about as basic as it can get. In fact, it is. It is as basic as we can get here. We have a function, f of x equals 2 to the x. This is the new function. And so before we even start, we should probably talk about the fact that what makes this an exponential function. And it's really simple. The variable x is an exponent. We really haven't seen that. Compare that to maybe something like this. You've seen exponents before, but it's never been the variable. So this is a squared equation or a quadratic equation over here. And notice there's just a number here that's the exponent. The base is the exponent. Same thing if we did x cubed. Of course, if we just had like 2x plus 1 or something like that. These all have your variable as the base, and the exponent is just a specific number for that specific problem. Now we're opening it up to where we don't even know what the exponent is. That's the part that's going to be changing the whole time. That's going to change depending on what values we pick for x. Based on that, that'll change the y value. So for the first one, and really for any graphs, I've been saying all year, we could always just say, you know what, I have no idea what this looks like, so why don't we just pick some points for x, plug them in, get the y values, plot them, connect the dots, make a graph. Let's do it. I'm going to pretend I don't know anything. I'm just going to go like this. I'm going to make up some basic values for x. This seems to be pretty standard starting point, where we have some negatives, we have some positives, and we throw 0 in there. All right, so most of this math you can just do in your head, although for the first one, maybe I'll do some work over the side just to show you. So the first thing I'm going to do is I'm going to put a -2 right in there. Okay, so that would be 2 to the -2. I'll do it over here. 2 to the -2 equals 1 over 2 to the +2. Just a little reminder of exponents, that whenever you have a negative exponent, you just relocate it to the other. If it's in the numerator, then you relocate it to the denominator, changes to positive. And then we just have 1/4. So this over here is 1/4. We do the same thing for -1. I'm going to take a -1. I'm going to put it in right there. That's 2 to the -1, which is 1 over 2 to the 1, which is 1/2. So we're going to have a 1/2 right here. We'll go a little faster now since these are a little easier. Anything to the power of 0. Anything to the power of 0. You need to know this right now and forever. 2 to the 0, anything to the 0 equals 1. That's just a rule. Anything to the power of 0 equals 1. 2 to the 1, now we're going to put a 1 in there, so 2 to the first power is of course 2, and 2 squared is 4. Well, that ought to give us a pretty good idea what the graph looks like, so let's, this next thing we would do is just sketch a little graph. So we're going to go to the left 2, and we're just going to go up 1/4, which is probably right about somewhere in there. Then we're going to go to the left 1 and up 1/2. Then we're going to go 0, 1, 1, 2, 2, 4. I don't think we need to plot any more points to see what's going on there, but we'll talk about it a little bit before we finish. So what's going on here is obviously the bigger numbers if I keep putting in bigger and bigger numbers for x, like 3, 4, 5, etc., it's just going to keep going higher and higher and higher. So we kind of know what's going on over here. It's going like this. Okay. But then if you want to think about down here, what's going to happen right down here is if I keep putting more negative numbers in here, like I did -2, I'll even do one more for you. If I put -3 in there, we would just get 2 over, or 2 to the -3, which is 1 over 2 to the third, which is now even smaller number, 1/8. But one of the most important things here with exponents that we need to know is that negative exponents do not make negative numbers. They make fractions like this, but they're not negative. So as this keeps going to the left, as I keep putting in more negative values for x, it's not going to drop down here. It's going to stay positive. It's just going to keep getting smaller and smaller fractions, like 1/8, 1/16, 1/32. And so we have another, kind of what we talked about in the last unit, we have an asymptote right here. This is an asymptote, meaning the graph is going to get closer and closer but never touch that line. So something like this. This was 1/8 right here. And for the most part, that's what exponential graphs look like. You just got your first one there. You have if the exponent is the variable, if that's the x in the exponent, then it's going to create a graph that kind of flattens out, but as you keep going to the right, it's going to get bigger and bigger very quickly, by the way, too. It's going to just start to shoot up at a pretty fast pace. By the time you're at, 10 or 20 over here, it's going to be way, way up there. So there we go. There's our starting point. Now all I'm going to do is mess around a little bit. Just keep putting different numbers in there and kind of the same idea each time. We're going to look for different patterns as we go. All right, so the next one, I went ahead and made it the same basic graph as last time, but I put a +3 there. So there's no reason to sit here and guess what it's going to look like, although I assume most of us, since we've done so many transformations of graphs, we probably know it's going to have something to do with going up 3. But let's just be careful on this one and plot some more points. In fact, let's plot the same points. Why not? So we're going to pick -2, -1, 0, 1, 2 again. Only this time, whatever we get for our answer, so if I take -2 right here, plug it in here, same as last time, I'm going to get 1/4, but then it's always +3. So it's 1/4 +3. And, this would be one time where, maybe we could just put 3 1/4. I hate to do that. I don't like the way those fractions look, but yeah, it might be the most helpful way to think of this right now. So that's 3 1/4. If I were to put a -1 in there, this is 1/2. Let me remind you again, I'll do it over the side. That's 2 to the -1 is 1 over 2 to the +1, which is 1/2. But then it's +3. So it's 3 1/2. And then that's it for fractions on this, because if I put a 0 in there, put a 0 in, any number to the power of 0 is 1. And 1 + 3 is 4. And then 2 to the 1 is 2, but 2 + 3 is 5. And 2 squared is 4. 4 + 3, 7. Make a graph. So what's going to happen here is, and we should probably know this now, is this thing's never going to drop below 3. If we go to -2, we get something a little bit higher than 3. We get 3 1/4, so it's going to be in here somewhere. Let's call this 4, so this would be down here. -1 is 3 1/2. 0, 4. 1, 5, and 2, 7. All right, so this time, last time I did not draw in a dotted line for the asymptote because the asymptote was just the axis. So I just, for whatever reason, I did not put a little dotted line right there. But now we need to do that. We have this spot right in here that's special. This line right here, because of this plus 3, the entire exponential graph has shifted up 3. So we need to kind of show that in detail, so we're going to go like this. And then we're going to connect our dots, and there's the graph. So same thing, just a same graph, just up 3. Everything you might have guessed. If you look back at the last graph, you knew that the last one was basically this, only it was down here. So now this one has gone up 3, same graph. Okay, let's do it again. This time you'll notice that I've changed this now. The exponent, the exponential part of it now has a plus 3 instead of the big old plus 3 over here. So what does that do? I don't know. Let's see. Let's see what happens. What are we going to do? We're going to put some more points in there. We're going to make some points. In fact, we don't know any better. Let's just try again the same ones. -2, -1, 0, 1, 2. See if that's enough. See if that gives us a confident idea of what the graph looks like. All right, so if we put a -2 in there, we take -2, we put it in for x right here. Pretty easy one. We get -2 plus 3, which is 1. 2 to the first power is 2. If we put a -1 in there, we get -1 plus 3 is 2. 2 squared, 4. 0 plus 3, right? 0 plus 3 is 3. 2 to the third is 8. Let's stop there for a second and think about this. If I keep going the way I'm going right now, all I'm doing is creating larger and larger numbers, which I get that already. I already know. I can see that this is going to go 2, 4, 8. The next one, I'm going to put a 1 in there. I'm going to get 4. That's 2 to the 4th is 16. These are going to keep getting bigger and bigger. So I have that idea of what's going to happen in the graph. What I'm missing, because of this plus 3, I'm missing what's going on more negative. I need to put in some more negatives. So in my mind right now, I'm thinking this. I'm thinking maybe I should put in a couple of these. Maybe even a few. Let's try that. I don't really even care about these ones. I know they're just bigger and bigger numbers. I definitely care about -3. -3 plus 3 is 0. That's kind of a special spot on our graph. So -3 plus 3, 0. 2 to the 0 is 1. Because anything to the power of 0 is 1. -4. -4 plus 3 is -1. 2 to the -1, I'll do it over the side again. 2 to the -1 is 1 over 2 to the 1, which is a half. And see, now we're getting our fractions. We want some fractions. We need fractions so we can feel what's happening to this graph. And then one more. Let's do one more. -5 plus 3 is -2. 2 to the -2 is 1 over 2 squared, which is 1/4. I don't know about you, but that feels like I might have enough points to get a good idea what's happening here. Let's make a graph. We could start, I could start graphing these ones first, or I can just kind of go down the list here. It doesn't really matter. So let's go down the list. -2, 2. It's right there. -1, 4. Right there. 0, 8. That's way up there. 5, 6, 7, 8. So there's our y-intercept right there. And like I was saying, I was already, as I was making these points, I was already visualizing that this graph, I don't really care anymore. I know that if I put a 1 in there, it's going to go way up here. I know if I put a 2 in, it's going to go even higher. So I'm kind of done with that. But I wasn't done seeing what was happening over here. I need to kind of feel, I need to feel this part right here. So we have -3, 1. -4, half. It's kind of like in there. And then -5 is a fourth, which is down there somewhere. So there's our graph. So what happened? Doesn't really look that different than the original, does it? It's really not. It's not that different. In fact, the only thing that really happened here is we shifted the whole graph to the left 3. If you remember when we have an x plus 3 in here, it's the opposite of what you'd think. So it went to the left 3. Which is hardly even noticeable, to be honest with you. I mean, it really isn't that big a deal. What happened was the point where it hits 1, in other words, at -3, if you put a -3 in here, you get a power of 0, which is 1. If this 3 wasn't here at all, and it was just x right there, then when you put a 0 in, you'd get 1. So basically, this went from 0, 1 to -3, 1. But other than that, this one just kind of looks the same. It looks like this. The asymptote is the x-axis again. Back to the original first problem. If you want to look back at that, you can. All right, time to change it up a little bit. The big change here is this. Okay, we now have a fraction as our base of our exponent. The first few problems I did for you, there was a 2 here. And so that created this growth. We kept doubling and the numbers kept getting bigger. If we put a fraction in here, a number less than 1, things are going to be a little different. But you don't need to know that yet. Let's just do it. Let's just do it. Here we go. Let's make another chart. I don't see why we don't just, we don't know any better. Let's just do this again. And here we go. Okay, a little bit of math to teach you again, just a reminder of how to handle these negative exponents. So the first one, if I put a -2, if I take -2 and plug it in right here, we get 1/2 to the power of -2, and then of course there's a -2 there. But the important part here is right here. You need to understand how to handle that. When you have a negative exponent, one way we thought of it was we were taking whatever was in the numerator and we dropped it to the denominator. Well, you also take the denominator and move it back to the numerator. But I have a better way to explain that. Whenever you have a fraction to a negative power, all you need to do is flip the fraction around and change the power. I change the sign of the power. Something like that. Let me say that again. Anytime you have a fraction to a negative power, take the fraction, take the reciprocal of it, so 2 over 1, or just 2, and then change the sign to positive. We have to change the sign to positive. We don't know how to actually do a negative power, so we have to figure out how to make it a positive power. When it's a fraction, you just flip the fraction, change the power. It's the same idea as before. We started with a fraction, so we end up with a whole number. Let's do it again. So now we have 1/2 to the -1 power minus 2, which is 2 to the 1 power minus 2, which is 0. So this is 0. Now we're going to put a 0 in there. I can do that one in my head. If I put a 0, if I take this x, 0, plug it in there, anything to the power of 0 is 1. So this is 1 minus 2. These last couple, we're going to have fractions. There's no way around it. We have fractions because I'm putting a positive number there now. So it's really just 1/2 to the first power, which is 1/2. So 1/2 minus 2. Well, I mean, I know it's negative 1.5. I hope you know that too. You could just write negative 1.5 there. You could do a common denominator if you want. It's 1/2 minus 4/2, which is negative 3/2, which is negative 1.5. I'm just going to write that, negative 3/2. And then the next one, the last one, I'm running out of room to do it, but it's 1/2 squared minus 2, which is 1/4. When you take a fraction and you square it, you're just multiplying 1/2 times 1/2, which is 1/4. 1/4 minus 2 is 1/4. This is getting a little messy here. Minus 8/4, which is negative 7/4. All right, here we go. This is kind of a big moment here because it's the first graph we're going to see where this is a fraction here less than 1. It's going to look different. Negative 2, 2. Negative 1, 0. 0, negative 1. 1, negative 1.5. Something like that. And then 2, negative, this is negative 7/4 is negative 1 3/4. 7/4 is 1 3/4. So this is negative 1 3/4, which looks like about right there. All right, so we have, we can see hopefully that this is getting closer. It's going to get closer and closer to this negative 2. And of course, that's because of negative 2 right here, minus 2. But more importantly, notice that this graph's now going like this instead of like this. It starts higher and goes down. Why does it go down? Because you keep halving everything. You keep multiplying. The bigger you make this, you actually are making the number smaller because you keep cutting it in half more and more. So whenever the base of the exponent, whenever this number is a number less than 1, like a fraction like this, then it's going to start like this and go down this way. Whenever this number is greater than 1, like a 2 or whatever, then it's going to start this way and go up. This will still move the asymptote. This number is going to still just change this dotted line, up and down, however. But this number is really affecting the way the graph looks. Maybe we should connect the dots, huh? Something like that. I think I'll stop there. I had one more, but I think this is enough to get you guys started. Don't forget you have a graphing calculator too to kind of learn from. You may not get to use it on a test because certainly you can do all this by hand. It's actually probably easier than the rational ones. But it's not bad to, to check them, plug some of these functions into the calculator and see what they look like and study that. You'll get to do a lot more of these in class tomorrow. So you'll have lots of practice. So until then, I'll see you soon. Work hard. Be nice.